Swayam Prabha. Digital India. Educated India.
Welcome to lecture 33 on time series modeling and forecasting. In the last lecture, we have discussed the spectral analysis of multivariate time series processes. In particular, we considered bivariate time series processes, and then we investigated the co-spectrum analysis of bivariate time series processes. We also saw that how coherency measures the extent of linear dependence between two time series for a particular frequency. Now, for a given set of observations, one has to estimate the spectral density function. In the univariate setup, we use periodogram analysis for estimating the spectral density function. In bivariate time series also, now we will extend the results of univariate periodogram for estimating the co-spectrum of bivariate time series. In this lecture, we will also discuss the spectral analysis of multivariate time series processes when you have more than two time series related to each other. So, for estimating the spectral density function of a bivariate time series process, we use bivariate periodogram analysis. So, suppose x t y t t equal to 1 to n are n observations from a bivariate time series. So, this is the observed time series. Then the bivariate periodogram is given by I omega equal to 1 upon 2 pi summation k equal to minus n minus 1 to n minus 1 gamma hat k e to power minus I omega k. So, just like the univariate case, we define the periodogram for the bivariate case also. Here gamma hat k is a 2 by 2 matrix with elements gamma hat x x k, gamma hat x y k, gamma hat y x k and gamma hat y y k. Further, gamma hat x x k is defined as 1 upon n summation t equal to k plus 1 to n x t minus x bar y t minus k minus y bar. So, actually gamma hat x y k is the sample autocovariance between x and y of lag k. Similarly, we define gamma hat x x k, gamma hat y y k and gamma hat y x k. You also observe that gamma hat y x k is equal to gamma hat x y minus k. So, once you have obtained gamma hat x y k, you can easily obtain the value of gamma hat y x k. Then the 1/1th element of this I omega gives you the periodogram for time series x t. So, I x x omega is equal to 1 upon 2 pi summation k equal to minus n minus 1 to n minus 1 gamma hat x x k e to the power minus I omega k. Similarly, we define I y y omega also 1 upon 2 pi summation over k gamma hat y y k e to the power minus I omega k. And then the cross periodogram is equal to I x y omega equal to 1 upon 2 pi summation over k gamma hat x y k e to the power minus I omega k. So, this is the cross periodogram. Then I y x omega is the complex conjugate of I x y omega, just like the co-spectrum density. Now, we have summation over t x t e to the power minus I omega k t summation over t y t e to the power minus I omega t, and then we take complex conjugate of this second term. The product of these two terms is equal to summation over t x t minus x bar e to the power minus I omega k t summation over t dash y t dash minus y bar e to the power minus I omega k t dash, then complex conjugate of this second term. And in fact, we have used this result summation t equal to 1 to n e to the power minus I omega k t is equal to 0. So, in the first term you can take x bar outside the summation sign and then summation over t e to the power minus I omega k t is equal to 0. Similarly, for the second term also. And then you can write it as summation over t equal to 1 to n t dash equal to 1 to n x t minus x bar y t dash minus y bar e to the power minus I omega k t minus t dash. In fact, we have used the result that the complex conjugate of e to the power minus I omega k t dash is equal to e to the power I omega k t dash. Now, we write t dash equal to t plus j, or you can say t j is equal to t dash minus t. So, you get summation t equal to 1 to n, and then you have summation over j, and the range of j is from minus n minus 1 to n minus 1. You get this minimum value of j minus n minus 1 when t dash is equal to 1 and t is equal to n, and you get j equal to n minus 1 when t dash is equal to n and t is equal to 1. And then you have x t minus x bar y t plus j minus y bar, because you are writing t dash equal to t plus j. Then e to the power minus I omega k, then t minus t dash is equal to j. So, you get this term. Now, we interchange these two summations. We take summation over j outside and summation over t inside. So, inside you have summation over t x t minus x bar y t plus j minus y bar, and then you can take e to the power minus I omega k j outside this summation sign. And actually summation over t x t minus x bar y t plus j minus y bar is equal to gamma x y j cap, and then in fact for obtaining gamma hat x y j you have to divide by n also. So, you get n here. So, for j equal to 0, you get the first term n times gamma hat x y 0, and then you have negative values of j, j equal to minus n minus 1 up to j equal to minus 1. So, you just replace minus j by j. So, you get this summation j equal to 1 to n minus 1 n times gamma hat x y, and then you are replacing j by minus j, and e to the power I omega k, and then you are replacing j by minus j. So, you get plus sign here, e to the power I omega k j plus summation j equal to 1 to n minus 1 n times gamma hat x y j e to the power minus I omega k j, and then you can write it as n times summation j equal to minus n minus 1 to n minus 1 gamma hat x y j e to the power minus I omega k j. And this is actually equal to 2 n pi I x y omega k. So, summation over t x t e to the power minus I omega k t, summation over t y t e to the power minus I omega k t, then conjugate of this is equal to 2 n pi I x y omega k. So, finally, you obtain this expression for the coperiodigram I x y omega k equal to 1 upon 2 n pi summation t equal to 1 to n x t e to the power minus I omega k t summation over t y t e to the power minus I omega k t, and then you have complex conjugate of this. In a similar manner, you can also obtain the values of I x x omega k and I y y omega k, or you just look at this expression, you replace y by x. So, you get x x omega k equal to 1 upon 2 n pi summation t x t e to the power minus I omega k t, and then you take mod of this and square of this mod. Similarly, I y y omega k is equal to 1 upon 2 n pi mod of summation t y t e to the power minus I omega k t whole square. So, you got this expression, these expressions for the periodograms of series x, series y, and the coperiodigram for x y. Now, in practice, how we estimate the spectral density, just like the spectral density for the single time series or these auto spectral densities, cross spectral density is also estimated using smoothened or averaged periodogram method. Remember, in For estimating the spectral densities of a single time series, how we proceed? We obtain the periodogram, then we smoothen it by averaging, by the method of averaging. For obtaining the smoothened value of periodogram, we just average the values in the neighborhood. Similar procedure we can apply here also for smoothening the periodogram. Now, suppose you write I x y omega k is equal to h x omega k h y omega k and then its complex conjugate, where h x omega k is equal to 1 upon 2 n pi to the power half summation t x t e to the power minus I omega k t. This is the first term, this one, and then h y omega k, its complex conjugate is this term, the second term. Then I x y omega k is equal to mod I x y omega k e to the power I phi x y omega k. You can write I x y omega k in this form. And h x omega k is equal to mod I x omega k e to the power I phi x omega k. Remember, mod of I x omega k is equal to mod of h x omega k. This you can easily verify from the expressions for I x omega k and h x omega k. Both have same mod value. Similarly, h y omega k is equal to mod I y omega k e to the power I phi y omega k. So, I x y omega k is equal to, you write it equal to h x omega k, h y omega k, then complex conjugate of this, and then you write the first term equal to mod I x omega k e to the power I phi x omega k, and then h y omega k, its complex conjugate is equal to mod I y omega k, and since you are taking conjugate, so you get e to the power minus I phi y omega k here. You get minus sign here then. So, here actually this part phi x omega k minus phi y omega k gives you the difference in phases of the two time series x t and y t. So, the phase of I x y omega k is the difference of the phases of h x omega k and h y omega k. You observe from here. Actually, this difference gives you the phase of I x y omega k, the co-periodogram of x y. Again, I just want to remind you how we have defined phi x y omega. Phi x y omega is equal to tan inverse q upon c when both are not equal to 0, and then you get these values when one of them is 0 or and the other one is positive or negative. Now, I x y omega k is equal to 1 upon 2 n pi summation t x t e to power minus I omega k t and into the complex conjugate of summation t y t e to power minus I omega k t, and you write it equal to c hat x y omega k plus I q hat x y omega k. So, actually c hat x y omega k is the real part of this product, and q hat x y omega k or minus q hat x y omega k is complex part of this product. So, when you get the real part, you have with x t you have cos omega k t minus I sin omega k t, cos omega k t minus I sin omega k t. So, when you multiply cos term of this summation with the cos term of this summation, then you get the real part, or you multiply the imaginary part is the term involving sin of this summation and the imaginary part of this summation, then you get the real part. Omega k t summation omega plus 1 upon 2 n pi summation t x t sin omega k t summation t y t sin omega k t. And for obtaining the imaginary part, say suppose you take imaginary part of this, then you have to multiply imaginary part of this first summation with the real part of second summation, or you multiply the real part of first summation with the imaginary part of second summation. So, you get minus q hat x y omega k is equal to 1 upon 2 n pi summation x t sin omega k t summation y t cos omega k t plus 1 upon 2 n pi summation x t cos omega k t summation y t sin omega k t. Then the co-periodogram c hat x y omega k is greater than 0. This implies that the corresponding frequency component oscillates almost the same phase and absolute phase difference. Means when mod of phi x y omega k, which is equal to mod of phi x omega k minus phi y omega k is less than pi by 2, and c hat x y omega k is less than 0 when mod phi x y omega k is greater than pi by 2. Then the highest positive value of c hat x y omega k is obtained when mod phi x y omega k is equal to 0. Actually, here I am using these expressions for these values of phi x y omega. Although these values of phi x y omega are for q x y omega and c x y omega, but same kind of expression you also get for q hat x y omega and c hat x y omega. So, the highest positive value of c hat x y omega is obtained when mod phi x y omega is equal to 0. When you get mod phi x y omega equal to 0, in this case, so c x y omega is greater than 0 here. Then highest negative value of c hat x y omega k is obtained when mod phi x y omega k is equal to pi. Again, you can verify from that those values of phi x y omega k. Then q hat x y omega k is greater than 0. This implies that phi x y omega k is greater than 0 and x t leads y t. If this is greater than 0, then you can say that x t leads y t. And q hat x y omega k is less than 0 means phi x y omega k is less than 0 and y t leads x t. And the largest phase difference is a quarter cycle, means one cycle is of 2 pi. So, quarter cycle means pi by 2. So, the largest possible phase difference is for phi x y mod phi x y omega k equal to pi by 2. Now, from the expression for I x y omega k, you observe that if you take mod of I x y omega k and then you take a square of this, then the square of mod of I x y omega k is equal to I x omega k mod of I x omega k and into mod of I y omega k. And for observing this, you just look at this expression for I x y omega k. From here, if you take mod of this term, take a square of this, then this is equal to mod of first term and then mod of second term. So, mod I x y omega k square upon mod I x omega k into mod I y omega k is equal to 1. So, suppose you want to use your periodogram for estimating the coherency. Coherency is equal to f x y omega upon f x x omega mod f y y omega. Then you replace f x y omega y, its periodogram estimate I x y omega k. You just replace this omega y omega k. Say. Then you replace this f x x omega k by I x omega k and f y y omega k by I y omega k to obtain an estimate of squared coherency. This is the expression for squared coherency. Then you get 1. So, you cannot estimate squared coherency using your raw periodogram. For estimating the squared coherency, you first obtain the estimates of cross and auto spectral densities based on a smoothened or averaged periodogram. And then you use those smoothened or averaged periodogram for obtaining an estimate of squared coherency. So, as such, you cannot use the raw periodogram, otherwise it will always give you an estimate 1. Now, we consider stationary vector processes and then spectral density matrix for a stationary vector process. So, spectral density matrix of the stationary process y t is given by f omega equal to 1 upon 2 pi g e to power minus I omega, which is equal to 1 upon 2 pi summation L equal to minus infinity to infinity gamma L e to the power minus I L omega. Just like the spectral density for a bivariate time series. Then h jth element of f omega is f h j omega is equal to 1 upon 2 pi summation L gamma h j L e to the power minus I L omega. Omega lies between minus pi to pi. Then for h equal to j, f j j omega is the auto spectral density function for the time series f j t. The jth time series of this vector process y t. And for h not equal to j, f h j omega is cross spectral density function of y h t and y j t. Now, we prove these results. Say f h j omega is equal to f j h minus omega, means the complex conjugate of f j h omega. And then using first result, you can easily verify that f omega is equal to f minus omega dash, complex conjugate transpose. Then we also prove this result, the spectral density of linear combination A transpose y t is A transpose f omega A. So, to prove the first result, we have f j h minus omega equal to 1 upon 2 pi summation over L gamma j h L e to the power I L omega. You have replaced omega by minus omega. So, you do not have minus sign here. Then you have 1 upon 2 pi summation over L gamma h j minus L. Actually, gamma h j h L is equal to gamma h j minus L, and then you write here e to the power minus I minus L omega. So, this is equal to 1 upon 2 pi summation L equal to minus infinity to plus infinity gamma h j L e to the power minus I L omega, and means you just write minus L equal to L dash, say, then you get this expression, and this is equal to f h j omega. So, we get the first result. To prove the second result, actually f h j omega is the h jth element of f omega, f j h minus omega is the j hth element of f minus omega. So, if you take transpose of f minus omega, then you get f omega, because f h j omega is equal to f j h minus omega. Then to prove this result, the spectral density of linear combination A transpose y t is A transpose f omega A, you simply obtain the autocovariance matrix or autocovariances of A transpose y t, and using those autocovariances you can easily obtain the expression for spectral density of this linear combination. And then you will observe that the spectral density of this A transpose y t is A transpose f omega A. So, the detailed derivation I am leaving here as an exercise for you. I have given you the hint for the solution. Now, A transpose f omega A is always greater than or equal to 0, because this is the spectral density of A transpose y t. So, it is always greater than or equal to 0. This shows that f omega is positive semi definite for all omega. Then spectral representation of the cross covariance matrix gamma L is gamma L equal to integral from minus pi to pi e to power I t omega f omega d omega. L varies from 0 plus minus 1 plus minus 2 so on. And then the hjth element of gamma L is integral e to power I t omega f h j omega d omega. So, this result is just corresponding to the bivariate processes, the cross covariance of bivariate process. In bivariate processes, you represent or the spectral representation of cross covariances is the same. Then the spectral representation of the process y t, suppose you have z omega equal to z 1 so on omega so on z k omega transpose, this is k dimensional complex valued continuous parameter process defined on the continuous interval minus pi to pi, means each of these say z 1 omega, z 2 omega and so on z k omega are defined on interval minus pi to pi. Expectation of d z omega 1 d z bar omega 2 transpose is equal to f omega d omega if omega 1 is equal to omega 2 equal to omega and 0 otherwise. F omega d omega is the covariance matrix of d z omega. Then the spectral representation of the process y t is y t equal to integral from minus pi to pi e to power minus I t omega d z omega. Actually, all these results are just parallel to the results for the spectral representation of univariate or bivariate processes. And here actually z omega denotes the random component of y t. The jth component of y t can be represented as y j t is equal to integral e to the minus I t omega z d z j omega. To prove this result, we observe that y t is equal to summation over j psi j x t minus j, and then we write x t minus j as its spectral representation. So, this is equal to psi j integral e to the minus I t minus j omega d z x omega. And then we interchange the summation and integral sign here, we take integral outside, summation inside. So, you get summation psi j e to the minus I t minus j omega d z x omega. And if you use spectral representation of y t, then spectral representation of y t gives you y t equal to integral e to the minus I omega t d z y omega. Then we compare these two expressions, this expression with this expression, and then you observe that d z y omega is equal to summation over j psi j e to the I j omega d z x omega, or you can write it as psi e to the I omega d z x omega. Then using the relation between d z x omega and d z y omega proved in the previous slide, here we observe that expectation of d z y omega d z bar y omega transpose is equal to psi e to power I omega expectation of d z x omega d z x omega transpose psi e to power minus I omega transpose. And then this middle term gives you f x omega. So, you get the final result. Next result is for the univariate process y t equal to summation j psi j x t minus j k square y x omega is equal to 1. And you can easily prove this result, k square y x omega is equal to mod f y x omega square upon f x omega f y omega, and then this is equal to, the numerator is equal to mod psi e to power I omega square f x omega square divided by f x omega into, then you write f y omega equal to psi e to power I omega mod f x omega psi e to power minus I omega. And then you obtain this expression equal to 1. Now, we define cross covariance matrix and cross spectrum. Cross covariance matrix between y t and x t is defined as gamma y x l equal to covariance between y t x t plus l, which is equal to summation over j psi j gamma x l plus j. And cross spectral density matrix between y t and x t is f y x omega is equal to 1 upon 2 pi summation over j psi j e to power minus I L omega, and then this is equal to psi e to power I omega f x omega. Omega lies between minus pi to pi. So, psi e to power I omega is equal to f y x omega upon f x omega. Now, suppose u t is a vector of white noise process, expectation of u t is 0, its variance covariance matrix is sigma, and expectation of u t plus l is 0. And then y t is generated by y t equal to summation j psi j u t minus j, where mod psi j, summation of mod psi j is finite. Then the process is stationary and has cross covariance matrices gamma y l equal to summation j equal to 0 to infinity psi j sigma psi j transpose. You can easily verify it. Then the spectral density function for u is f u omega is equal to 1 upon 2 pi sigma, because this is a purely random process, and f y omega is equal to 1 upon 2 pi psi e to power I omega sigma psi e to power minus I omega transpose. Just we have replaced x t by u t here, and then we are taking the spectral density of u t in between. Then cross covariance matrices between y t and u t is y gamma y u l is equal to psi minus l sigma if l is less than or equal to 0, and 0 if l is greater than 0. To prove this result, you just write y t equal to summation psi j u t minus j from here, and then you multiply it by u t minus L, and then you try to find out the expectation. And remember, u t is a purely random process. So, ultimately you find this cross covariance matrix as psi minus L sigma if L is negative, and it is 0 if L is positive. For demonstrating our results, we used the time series of first differences of logged series of real GDP, that is growth rates, and spread S t, which is defined as long run interest rate capital R t minus short run interest rates small r t. And then we have data from 1959 quarter 1 up to 1998 quarter 4. And then we have drawn spectral density, and we have also studied the coherency between these two time series. So, these are the growth rates of real GDP, and this is the graph of spread. Then the squared coherence between growth rate and spread is statistically significant at low frequency. This is the graph of squared coherence. So, you observe that, and this line actually gives you the 5% threshold values. So, anything above this may be considered as significant. So, you observe that at lower frequencies the squared coherence is significant. Then these are the spectrums of growth rate and spread. Again you observe that this spectrum of growth rate is also concentrated at lower frequencies, and this is the cross spectrum of 2 time series. Again the cross spectrum of these 2 time series is also concentrated as lower frequencies, and which is quite obvious because you observe higher coherency at lower frequencies. So, in this lecture we have considered the spectral analysis of bivariate and multivariate time series processes. In particular, we have considered the periodogram analysis of bivariate processes. Then we can use the periodogram for estimating the spectral density, and we also observe that you cannot use the raw periodogram for estimating the squared coherency, because it always turns out to be 1. So, for estimating the squared coherency you should always use a smoothened periodogram. Then we also observe the spectral density of multivariate processes when you have more than 2 time series, and the periodograms for multivariate time series processes. We demonstrated the results for the real data set, and you observe that the graph of squared coherency gives you the frequencies at which the 2 time series are highly correlated. And in the example actually we have observed that the lower frequency at which we observe more coherency, we also observe that the co-spectrum is concentrated at those frequencies, which is quite obvious also because those frequencies have higher squared coherency. So, here I am going to stop. Thank you.
Hi, I'm Chitwan Lalji, a PhD student of Health Economics under the supervision of Dr. Debayan Pakrashi from the Department of Humanities and Social Sciences, IIT Kanpur. In one of my essays, I am interested in understanding the relationship between consumption of fruits and vegetables and various health indicators. Health indicators, both subjective and objective health indicators like mental health, self-assessed health, various measures of blood pressure and various measures of cholesterol. Measures of blood pressure like systolic and diastolic BP, you have your incidence of high BP, MAP and incidence of high MAP. And as far as cholesterol is concerned, I have tried to concentrate more on total cholesterol, good cholesterol and incidence of high cholesterol. Now, before I go on to what have been my major contributions and various policy implications, I would like to briefly tell you about the policy initiatives of WHO and various countries. The WHO, that is the World Health Organization, it started with a campaign of 5 a day. That is, you should have 5 portions of fruits and vegetables per day. That would be approximately, you could say, 400 grams of fruits and vegetables. Now, a portion, before we go further, I'll just tell you what exactly is a portion. One portion is equivalent to a medium-sized apple, or one small glass of fruit juice, which is approximately 150 milliliters, and maybe 3 teaspoons of vegetables. So, the WHO went with the 5 a day campaign, which was further taken up by various countries countries like UK, Netherlands, Germany, Norway, they adopted the 5-a-day policy, while some went for expansionary dietary policies like France, Australia, Canada, Denmark. So, for example, Australia, it went for 2+5 policy, in which it said that you should consume 2 portions of fruits and 5 portions of vegetables per day. And USA went for a policy of fruits and vegetables more matters. That is, you must consume more and more fruits and vegetables. Now, irrespective of these expansionary dietary policies and dietary propagations, it has been found that only 28% of women and 25% of men, they actually meet the recommended dietary norms of 5-a-day portion. So, the major contribution of my work is firstly to find an association between fruits and vegetables, whether there exists a relationship between fruits and vegetables and health indicators, and if they exist, whether due to heterogeneity in the data. So, I will be doing it according to age, by gender and by your weight. So, apart from that, I will go for policy recommendations, in which I am basically studying how much fruits and vegetables matter. Apart from that, which type matters more. So, for that I have taken data from the Health Survey of England. Health Survey of England is an annual survey which takes data, which conducts information regularly on demographic and socioeconomic characteristics. You have your lifestyle behaviors, like an individual smokes or doesn't smoke, alcohol consumption, you have your sedentary and physical activities, and you have various health indicators also which have been collected. Before I go on to what exactly is my research, I would like to concentrate more on fruits and vegetables, like what kind of questions were asked in the survey. Questions like, what kind of fresh fruit do you eat? Did you eat any dried fruit yesterday? Don't count dried fruits in cereals, cakes. Apart from that, for vegetables, they asked how many tablespoons of vegetables did you eat yesterday? So, approximately after this whole survey was conducted, data was converted into portions of fruits, and like for example, 3 tablespoons of vegetables is equivalent to 1 portion. So, data was converted and provided to the users, that is us, from the UK Data Health Survey. So, the major contributions of my paper is that I found a strong negative association between intake of fruits and self-assessed health, then various measures of blood pressure like mean arterial pressure, high blood pressure, systolic and diastolic BP, and your total cholesterol. Apart from that, I have found a strong positive association between consumption of vegetables and good cholesterol. So, it is recommended in a way that if you want to control your blood pressure, you must consume more and more fruits, and as far as vegetables are concerned, they impact your good cholesterol. Apart from that, I went in for a falsification test. A falsification test is basically conducted to know whether the model that you have adopted and the conclusions that you are drawing are not spurious. So, if a falsification test is done to know, in a way it is tested by seeing an indicator, a health indicator which is not being impacted by your consumption of fruits and vegetables, and then we see whether there is significant result or not. If there is no significant result, that means your model is good and your results are non-spurious. So, what we did is, for falsification test, we took ear complaints and infectious diseases. Now, ear complaints, like if you are deaf since birth or you have some kind of imbalance, body imbalance, that is not being impacted by your consumption of fruits and vegetables, and we did find insignificant results. Apart from that, infectious diseases like HIV, AIDS, etc., we found similar insignificant results, indicating that our results are non-spurious. Apart from that, we went, since there was a lot of heterogeneity in the data, like by gender, by age and by weight, we did the regression analysis. We found results which stated that as far as fruits are concerned, it impacts a male's health more than a female's health. So, it is basically said a man should consume more fruits to impact his health, whereas As far as vegetables are concerned, they impact a women's health more. But this has been only seen as far as cholesterol is concerned, the various measures of cholesterol like total cholesterol, good cholesterol and your incidence of getting high cholesterol. Now, after this we went in for a policy implication, and in the policy implication we tried to find two policy implications, what matters and exactly how much portion matters. So, as far as how much portion matters, we have found that on an average, 5 or more portions of fruits impact your overall health, that is your self-assessed health, your MAP, your incidence of high MAP and incidence of high BP. But if you want to have a good mental health, so you can optimize your mental health by consuming 3 or 4 portions of fruits as well. And similarly, as far as self-assessed health and total cholesterol is concerned, an individual must consume 4 to 5 portions to optimally have the impact of consumption of fruits. Apart from that, vegetables have had a very little impact on your health. It only impacts your incidence of getting high MAP and high BP, and it's seen that only it impacts when you consume 5 or more portions of fruits. So, an optimum consumption of 5 or more portions of fruits and vegetables are recommended, but fruits have a more impact on your overall health on various measures like self-assessed health, mental health, your various measures of blood pressure and various cholesterol levels. Another thing that we find is which type of fruit matters. It has been seen that all size fruits, they impact your self-assessed health, your systolic and diastolic blood pressure, your mean arterial pressure, your high BP and incidence of getting high MAP and high cholesterol. But we find that as far as frozen fruits or canned fruits are concerned, they help in regulating your incidence of getting high MAP or high BP, but it has a trade-off. That means there is something negative happening. It reduces the good cholesterol in your body. Apart from this, if you have an incidence of getting high cholesterol, it is recommended that you must consume fruit juices because it has a impact in reducing your probability of getting high cholesterol. And dried fruits, they impact your self-assessed health. As far as vegetables are concerned, very little impact has been seen. It has only been seen in case of portion of salads and its association with self-assessed health. Another thing that they have seen is vegetables in composite, they have an association with good cholesterol. So, overall my research basically says that there is an association between consumption of fruits and vegetables and various health indicators, and it is highly recommended that an individual, in order to be healthy, must consume 5 or more portions of fruits and 5 or more portions of vegetables per day, but fruits have a more impact on your overall health. Apart from that, all size fruits, they have a better impact on your overall health, your mental health, various measures of blood pressure and cholesterol. So, thank you.
Hello and welcome to this piece of literary snippet. We usually know William Shakespeare as the most revered figure in the history of English literature. But we often tend to forget that he has also been one of the most hated figures in literature. And here I am not talking only about those boys and girls who have to memorize long sections from Macbeth or King Lear or Julius Caesar before they can go and sit for their school or college exams. But I am also talking about people who are themselves quite famous authors. Tolstoy, for instance, considered the writings of Shakespeare to be, and I quote, crude, immoral, vulgar and senseless. George Bernard Shaw absolutely loathed Shakespeare, as he did Homer. But perhaps no other criticism about Shakespeare is more damaging than the one which says that Shakespeare is a marvelous storyteller, provided someone has told him the story earlier. Now, this piece of criticism is particularly damaging because it is true. None of Shakespeare's plays contain any original story whatsoever. They are all written using pre-existing materials, pre-existing stories. Now, does that diminish the stature of Shakespeare as a dramatist? Well, I'll leave that for you to decide. See you in the next episode of Literary Snippets.